Well, hey there, guys. Mr. Carlson here again, and in this video, we're going to talk about mass-to-mass conversions. So far, the only type of conversions in these reactions that we've done are the first one we did was mole-to-mole conversions. That's where basically we were looking at these numbers here that are in front. In fact, I'm going to put a 1 here for this one. We looked at those numbers here, and that's telling us the ratio of how much moles of each substance we have. So right here I've got 1 mole of N2 gas for every 3 moles of H2 gas, and for every 2 moles of ammonium for this. So if the problem says, hey, you've got 7.6 moles of hydrogen gas, how many moles of NH3 are you going to make from that? And so we use this. This is our conversion factor right here, 3 moles of H2 for every 2 moles of NH3 to figure that out. The other type of conversion that we did was moles to mass, or mass to moles, either way. And that one was like if I have a certain amount of grams, so a mass of hydrogen, can I figure out how many moles of this I'm going to have? Or the problem could say if you have a certain amount of moles of this, what's the mass that you're going to have of this in the end? And so for that, remember our conversion factors, we had to bring in a new type of conversion factor for that, and that was where we use the periodic table, and we use the molar masses of the elements down here to figure that out. And now today what we're going to do is we're going to combine those two things together, and we're going to look at mass to mass conversions. So basically, it's like in this problem right here, it's telling us, hey, you've got 2.7 grams of hydrogen gas that reacts. How many grams of NH3 is going to be formed from that? So it's going from grams of this to grams of that, okay? And we have to use our molar masses to kind of go between those two things. So let's get started and let's do that one right now. Let me get rid of this. Okay, so again, just like in all these problems, the first thing that we're going to do is we're going to write out the thing that we are starting with, or the thing that the problem is giving us. The problem is telling us that we have 2.7 grams of H2. So that's the first thing that I'm going to write down, 2.7 grams of H2. And I need to convert this into grams. I want to figure out how many grams of NH3 do I have if I've got 2.7 grams of H2. Well, I don't have a conversion factor that relates those two things. I don't have a conversion factor that tells me how many grams of this for how many grams of this. The only thing that I do have in this is I've got the molar ratio, so I know that there are 3 moles of H2 for every 2 moles of NH3. That's the only relationship I have between NH3 and H2, is just that. That's the only thing that I've got. I don't have grams of H2 for every grams of NH3, so I can't use that to just multiply this in one step. This is the only relationship that I know from between NH2 and NH3. So what am I going to have to do to convert between grams of H2 and get it into grams of NH3 using this? Well, the first thing that I'm going to have to do is, if I want to be able to use this, I need to figure out how many moles of H2 I have, not how many grams. So then I ask myself, can I convert this from grams of H2 into moles of H2? And the answer is yes. That's what we were doing last week, basically, because we can use the periodic table here, because these numbers down here at the bottom are giving us the grams per mole. So for hydrogen, for example, hydrogen is 1.01 grams per mole, 1.01 grams of hydrogen for every 1 mole of hydrogen. That's what the molar mass is telling us, right? Grams per mole. So if we come back to this, my first step here is going to be, I want to convert this grams of H2 into moles of H2 using the molar mass. So my conversion factor is going to be the grams per mole. But now here it's H2 though, not just H by itself. So I have to figure out what is the mass of H2. Well, hydrogen, we just saw in the periodic table, is 1.01 grams per mole, okay? But there's 2 of them in here, so I'm going to multiply that by 2. That means the molar mass of H2 is 2.02 grams per mole. And again, remember, that means that for every 1 mole of this, it is 2.02 grams. So I'm going to plug this in. Remember, we can rewrite this as just like this. We can write it out the long way, 2.02 grams of H2 for every 1 mole of H2. Okay, that's the same thing. And this is how we're going to plug it in here. And then we ask ourselves, well, I could put 2.02 grams on top, or I could put 2.02 grams on the bottom and have 1 mole on top, or I could flip it around. Well, I want to get rid of grams. I'm trying to convert into moles. So I'm going to put moles on top because what I want goes on top. So it's going to be 1 mole of H2 for every 2.02 grams of H2. Okay? And now if we look, grams of H2, that unit there is diagonal. And when we have units that are diagonal like that and we divide them, they're going to cancel out, leaving us with moles of H2. So if I did the math right now, just as I have it, it would be 2.7 times 1 divided by 2.02. And if I did that math, it would tell me how many moles of hydrogen gas I have. But that's not what I want to figure out. I want to figure out how many grams of NH3. So I'm really not even halfway there yet. I've only converted into moles of H2. But now what I can do is I can, now that I'm in moles of H2, I can convert into moles of NH3 because I've got this conversion factor here that relates moles of H2 and NH3. So what I'm going to do is I'm going to multiply by this conversion factor here, and that's going to tell me how many moles of this I have. And then once I know how many moles of this I have, then I can, just like I did here, I can convert that into grams of NH3 using the periodic table. So let's plug this in down here. Let's see. We want to figure out moles of NH3. So moles of NH3 is going to go on top. There are 2 moles of NH3 for every 3 moles of H2. Okay? Moles of H2 diagonal from each other will go away, leaving me with moles of NH3. Okay, now I'm halfway there. I've got moles of NH3. And now all I have to do is convert it one more time into grams of NH3. And so now I have to kind of do the same thing we did right here in this step. I got to figure out what's the mass of NH3. So we've got nitrogen. Go to the periodic table here. Nitrogen is 14.01 grams for every mole. So 14.01 grams. And there's only 1 of them, so times 1, which would just give us 14.01 again. And then I've got hydrogen. Hydrogen is 1.01 grams. There's 3 of them. So 3.03. We're going to add those together to get us the total mass of the whole compound. So 14.01 plus 3.03, we should get 17.04 grams per 1 mole. There's my conversion factor to get from moles of NH3 into grams of NH3. I'm going to put grams on top this time because I'm converting into grams. So there are 17.04 grams of NH3 for every 1 mole of NH3. And hey, look at that. Moles of NH3 cancels out, leaving me with grams of NH3, which is what I'm trying to figure out, grams of NH3. I can go through now and do all the math, and it will give me my final answer in the end. So it would be 2.7 times 1 divided by 2 times 2 divided by 3 times 17.04 divided by 1. Plug that in the calculator, crunch the numbers here, and we should get, looks like 15.2 grams of NH3. And that is the final answer for that one. Okay? Let's do one more example here, just one more example. Here we go. We got another balanced equation up here. And this one says, determine the mass of H2O that is produced from the decomposition of 25 grams of ammonium nitrate. This is ammonium nitrate right here, NH4NO3. It's kind of a big molecule. 25 grams of it is what we're starting with. And we want to figure out how many grams of this are we going to make. So just like the previous problem, we're going to start off by writing out what we're given. We're given 25 grams of NH4NO3. And I want to convert this into grams of water. So the first thing I have to do, so just like in the previous problem, we're starting with a mass of something. We're going to have to convert it into moles, and then out of moles into mass again. So from mass to moles, and then from moles to mass. So let's figure out how many moles of ammonium nitrate I've got. Well, the way to do that is I've got to figure out the molar mass of this. So this one's kind of a big one here. So we've got nitrogen. So nitrogen is, let's go to the periodic table here. Nitrogen 14.01. 14.01 times, how many do we got in here? We've got 2 nitrogens. So 14.01 times 2. We've got hydrogen. 1.01 times 4. And we've got oxygen. Oxygen is 16.00 times, there's 3 of them. Okay, let's crunch the numbers here. Gotta get out my calculator here. 14.01 times 2, 28.02. 1.01 times, 1.01 times 4. I don't know why I needed a calculator for that. 4.04, and then 16 times 3 gives us 48.00. Add these all together, and we should get 80.06 grams per 1 mole. All right, there's the molar mass, so I'm going to put 80.06 grams on the bottom of NH4NO3 for every 1 mole of NH4NO3. Remember, we put moles on the top because that's what we want. Grams of NH4NO3 goes away, leaving us with moles. Now I can go from moles of NH4NO3 into moles of water because I know that there's 1 mole of this for every 2 moles of this. So 2 moles of H2O for every 1 mole of NH4NO3. Moles of ammonium nitrate here will go away, leaving us with moles of water. And then from moles of water, I can jump into mass of water. So I have to figure out the molar mass of water. Let's see. Hydrogen, 1.01 times 2. Oxygen, there's only 1 oxygen in there, so 16 plus 2.02. 18.02 grams per 1 mole. So up here, we're going to put grams on top because I'm trying to figure out grams of water. So 18.02 0.02 grams of H2O for every 1 mole of H2O. Moles of H2O will cancel because they're diagonal. Go through and crunch the numbers here. So 25 times 1 divided by 80.06 times 2 divided by 1 times 18.02 divided by 1, and we should get 11.3 grams of H2O. And that's the final answer for that one.